Hello everybody, my name is Chris Brady, author of the Boeing 737 Tech Guide and the Boeing 737 Tech Site. And this video is about the FMC. Now you're probably thinking I've already done one on the FMC. I have, but that one focused on the hardware. So that was the actual unit in the eBay, the CDU, and a lot about the maintenance pages and that sort of thing. And by checking and the like. This one is, or this series of videos, because this is just the first of 4, I've had to break it down because the subject's so broad. This one's much more pilot orientated. It's much more about how you use the FMC on board in the flight deck. So as I say, I've had to break it down into 4 because there's a lot to cover in the FMC, and really when I was thinking about how to do this, because I'm doing this particular subject because you guys asked for it, I wanted to think, well, what can I add to your knowledge? What do you want to get from this that isn't already in the FCOMs? Because the FCOMs are quite comprehensive, but really they're also quite limited in that they just simply show you what you see and what the input fields are. That's kind of it. What I'm going to try and do is take you through the development of the FMC, starting with update 10.0, which was issued with the first NG, right the way through to update 14.1, which actually isn't even out yet. That's due for certification in autumn 2022. And I'll be taking you through all the developments and hopefully giving you a little bit of background on why each development was brought in and what it adds. So that's a little bit more than you get from the FCOM. Also, again, in an attempt to make what can be a dull subject, interesting, I'll take you through all of the available options. So there are actually quite a lot of options, a couple of dozen, which have got some very capable functions, some of which you'll have at your airline, but you're very unlikely to have all of them. So with this, I'll be taking you through all of those possible options, so you can see what you're missing if you flew for other airlines, or indeed if you're the fleet tech captain, then you can get an insight into what's available. The last thing I guess I've got to say is that as I say, I have broken these up into 4. I think it's 10 to 10.2, 10.3 to 10.5, 10.6 to 8, and then update 11 onwards. Just because you're flying, say, update 12 doesn't mean to say that the update 10 video won't be of interest. It will, or it should, because each of the features were introduced along the way, and they are still operational in later updates. So it's probably well worth you catching all 4 if you've got the time. Okay, great. On with the video. So the contents of this video are update 10, 10.1, 10.2 and 10.2A. As always, please treat your company training and their manuals as the authoritative source of information. So starting with update 10, this was launched in 1997, and it was developed specifically for the new 737NG. 10.0 was specifically for the 737-700, which was the first of the NGs to be certified. The 800 first used 10.1, and the 600 first used 10.2. The 900 actually came quite a way down the line. 10.0 combines all of the features of the previous updates, or the previous latest updates of the Classic, which were 7.4 and 8.4 at the time. 7.4 being the single FMC version, 8.4 being the dual FMC. There never was any update 9. That didn't exist. For whatever reason, Boeing skipped straight to 10 from the 7 and 8 series. And 7 and 8 actually ran in parallel with each other. So, for instance, 7.0 and 8.0 had identical features, except what the 7 was for the single FMC and 8 was for the dual FMC. There was actually an issue of 7.5 and 8.5 issued after update 10, where they just decided to backdate a few of the features of 10, but I think most operators had switched to 10 by that time. Anyway, the system designs, as I've already said, really, it incorporated backward compatibility to both the EFIS and non-EFIS classics. It took a little while to catch up to all of those, but it was certainly eventually available to all of the classics. The nav database went from 256k to 4 million words, depending on the update version. So it did become quite large, and that really was a function of the increased range of the NG. Once they could go outside of a whole area, say North America, down South America, or even transatlantic, particularly with the BBJs, then of course you'd need a European and North American database. And same for other parts of the world as well. Again, particularly the BBJ, which is a bit of a globetrotter. Update 10 will only run on the 2907A for FMC, which was the last of the old version of FMCs. Further details of that are on my original FMC video, the one about the hardware. So for the NG, there were certain features which were specific to that, as opposed to the classics. Now I've got two screenshots on the right there of the U10.2 page, which is probably one you don't look at that often, but these are both fairly up-to-date photos, certainly taken within the last year, and you can see that the difference there is the model engine data field on the NG and the Max, and that is telling you the loadable performance database, which is never been available as an option on the classics. In addition to that, first principle takeoff speed calculations are also incorporated, and of course VREF-based flat maneuver speeds, which we have on the NG and the Max to replace those fixed gross weight increment block speeds of the classic. The old 210, 220, 230 knots, depending on your aircraft weight. One of the other big step forwards, if you like, features, and it's not something we use as pilots a lot, but it is really handy to manage your fleet, is a software options page. As a reminder of the breadcrumb trail to get to that, up in the top right you can see from the initref index there's a field called maintenance. So you go maintenance FMCS. You may not be asked to choose left or right if you've got a dual FMC setup. Then you go to software options. First page you can ignore for now, although we'll come back to it in some later videos. But then you get to the meat of it, which are the options pages, and these are listing what options your airline has got selected. Now this is showing 2.5 pages of options, so it's quite a well-equipped aircraft. Most airlines have about 1 page of options, some maybe 1.5, some less than 1. But there they all are, and they're actually written there in plain English, although there's often not a lot you can infer from a title. So I will discuss with you and explain each of these in sequence as we go through. This is a full list of software options. So the previous slide showed what was available on that aircraft, and I did choose a photo of an aircraft which had quite a lot of options, but this is the full list, and I don't know, looks like there's at least 30 on there. Some of these go right back to things that were introduced in update 5, and they come all the way to the present day with update 14.0, which had 3 new features in it, or 3 new optional features. I will go over the ones that were pre-update 10, just to get everybody up to speed in all of the options, because again you may not have these options selected. Like I say, what I'm trying to do is not only explain everything, or as much as we can manageably do here, but I would quite like to just show you what all of the options are, because these are quite interesting, you know, when you jump in and out of different aircraft. Although ideally an airline will have all the same options on all its fleet, I know for a fact that doesn't happen, and certainly if you're changing airlines, you know that there can be quite a significant difference in the options available. So I'll go through all of them with you, just so you know what they all are. Alright, so starting with the earliest, I'll do these in chronological order. The first actually came in 1990 with update 5, and this was the well, misleadingly named for high idle descent, and I'll explain why now. So this is a classics only option, so if you're on the NG, you can fast forward past this slide. But those of you still flying classics, and certainly those of you who were flying them a long time ago, you might remember that in the late 1980s that there were 2 double engine flameouts due to ingestion of hail into the core. And that was the old CFM56-3 engine. As a result of that, there was an AD issued, and that set a minimum M1 of 45% during heavy rain, hail or sleet. Now, in the climb and the cruise, that's no problem. But in the descent, that would be a real problem. And you would have to really quite actively study the Met and or the weather radar and see whether you're going to encounter any of those conditions and adjust your top of descent point accordingly. Over around about 3 years, it took for CFM to come up with various engine modifications which would solve the root cause of this problem, and these things included cutback fan booster, splitter fairing, and this allowed more of the ingested rain and hail to be sort of centrifuged out by the fan rotor away from the core into the bypass flow where it can't do any harm. The problem was taking all this heavy rain and hail down the core. That's where it would put the fire out. Anything going, you know, around the bypass, it's fine. It just gets spat out round the edge and no harm done. Now, apart from the splitter fairing, the other big part of this, and certainly the most visible part, was that they changed the shape of the spinner from the old conical shape to an elliptical, sort of round-nosed shape. You don't see conical ones anymore because of the AD mandates that they all be changed. But certainly if you look at any old photos of original 737, particularly 737-300s and 400s, you will see that they had quite a sharp pointy spinner. That didn't give the necessary geometry to fire the rain down the bypass. So that was changed. By September 91, this 45% M1 restriction had been lifted if the engines had the modifications. What Boeing stroke General Electric did with the FMC is that they put this high idle descent option in here. And by high idle, what they mean is not 45%, but you know the regular 32% M1. So it's high idle as opposed to ground idle. I say it really is quite confusing nomenclature, but it's not the 45%. So if you are flying any classic now, you should see this option if you check the software options. And just so you know, again, to spell it out, this just means the regular 32% M1 descent, which is planned into the FMC top of drop descent planning calculations, not the old 45% M1. So that's what this one's about. The next one was runway offset remaining in either feet or meters, and again this is an old option, goes back again to update 5 in 1990, and all update 10 does, and the only reason I'm including it here is because it's now listed in the software options pages. So there's various different kinds of this, as you can see from the photos in the left hand column. You can either be displayed as takeoff shift or as runway remaining. It can also be displayed in either feet or meters. You don't see this displayed a lot now, even if your aircraft has got this option activated. So again, if you go through the software options pages of your aircraft, you know, tomorrow, having watched this video, and say, oh, it says there it's got runway remaining, I've never seen that on my takeoff page. The reason is that from update 10.2, this was inhibited when GPS was acting as the primary position updater, and the reason for that is that GPS is far more accurate than some guesstimate of a takeoff shift in meterage from when you press the toggle buttons on the thrust levers. So it's kind of been superseded by technology. You have to remember that when this came in, GPS wasn't a thing. It certainly wasn't fitted to classics in 1990. So this was just the last way of getting a good position update before you got airborne. Next one came in with update 6 in 92, and it's a beam waypoint, and this is really useful, and it's still not a very common option. And I know I get I fly with guys who come across from the Airbus and say, oh, the 737 hasn't got beams. Well, actually, yes, it has. It's just that, you know, this airline hasn't chosen to pay for the option. Again, if I haven't mentioned it before, and I can't remember whether I have or not, all of these options are available at a price. There are very few standard options. I mean, the high idle descent was a standard one, but all of the rest pretty much are all, you know, for the appropriate fee. So that's why we don't all have them. So what this is, for those of you that haven't seen it, is it's a great little feature. When you're cleared by air traffic direct to, you know, wherever, any waypoints that are within 100 miles actually get transferred to the new path and appear as new waypoints. Just the last two letters are dropped and replaced with a 01. If you get a second direct, then and you do the beam function again, then the newer beams will end 02. And you can see on the photos there, there's a photo of the nav display, and also of what legs looks like when you've done the beam. So it's quite useful for fuel checks, you know, and timing checks. So I know why it isn't standard, because it's a money raiser. You know, you can argue whether it should be that way or not on your own, but that's it. Okay, next one's altitude and speed intervention, and you may have this on your fleet, or you may see blanking plates over the speed and altitude intervene buttons on the MCP. The photo there shows them revealed, and on the software options you'll have it. If it's enabled, it'll show up on that page. Again, it's quite an old option, but it hasn't really caught on that widely. I'd say it's probably about 50-50 on the airlines that have got this or not. So again, for those who haven't got it, how it's used is that when you press either of these buttons, so the speed intervene button, you press that, it deletes the next speed restraint for you off the legs page. If you press alt intervene, it deletes the next altitude restraint in either a climb or a descent. I should say that from 10.6, the altitude intervene logic was revised to stop you accidentally deleting altitude restrictions on the approach. You know, if you've got fat fingers and you go to reset an altitude on the MCP and just accidentally catch the altitude intervene button, you could delete maybe a platform altitude or something on the approach, which obviously has got safety implications. So the logic for that was changed, but I'll come on to that when I get to 10.6 in a couple of videos time. Alternate destinations. Again, this is a really, really useful feature, and it isn't standard on the 737. I wish it was, but there we go. And this has been around for ages as well. It's since 1992. That this has been there. There was actually a way of getting to this through a cunning series of button pushes, but unfortunately Boeing took away that cheat code to get in. I did publish it on my website years ago. I think I had it in the book as well. But anyway, it doesn't work anymore, so I've removed the info on how to get there. But what this is on the initref index, you got this alternate destination prompt, and when you press it in flight, it gives you the nearest 5 airfields, and if you select one of those airfields, it'll give you all the fuel, speed, distance, time calculations to get there, either direct or from the missed approach of where you're going to. So really, really useful function. If you feel the need for it and you've got any leverage on your fleet office, then maybe put in a request for it. So you see how much money your airline's got to pay for the upgrade. CDU message recall, probably not quite as useful as the others, but nevertheless it's got a place, and you do wonder why this isn't standard. It's an old feature. It's since 1992, update 6, and what this did was this put a message recall on the initref index page, and when you pressed it, it would give you a list of all of the scratch pad messages which have popped up on the CDU, or certainly all those whose display criteria are still true. So it's again a very useful function, and it's still available, but it is an option, so sadly you don't often see it. Planned fuel entry, this one that is much more common, I'm pleased to say. It's been around for a surprisingly long amount of time. This again is an update 6 feature. And this enables you to enter the planned fuel, so obviously on the turnaround, while you're still entering the route and doing your bits and pieces pre-flight, you can put in the planned fuel, and that will enable the FMC to calculate the gross weight and do all of the other predictions and calculations, things like the altitude capability, based on that planned fuel. Now, if the refuel has been a bit inaccurate on how much he's put on, and you can actually see it in this photo here. So the planned fuel was 8.8, but for whatever reason 8.9's gone in the tanks. Then not to worry. As soon as the engines have started, planned fuel is disregarded, and the FMC works on the actual fuel. So you needn't worry if you're too far out. Certified takeoff speeds, again another old option going back to 92. This basically will display QRH or V speeds depending which version you've got. I think QRH speeds was the earlier one. Anyway, one came in update 3 and one came in update 6. So these are really old functions. A lot of debate in the 737 community as to how useful they actually are, because obviously these are just pure balance field figures. They don't know what obstacles are out there. They don't know a lot of things really. It's just absolute basic QRH figures, and really what it is it's a for me anyway, it's a gross error check. It's kind of a common sense check. Are the numbers we've calculated between us by whatever method, tables or an EFB, are they sensible?
Manual RMP entry, again, this has been around for a surprisingly long amount of time, because you tend to think of this as a sort of RMP, AMP, sort of LNAV, VNAV approach type function, which of course it is. But Boeing fairly far-sightedly had the facility for crew to manually enter or overwrite the nav database RMP figure, since 1994. As with most things, when you overwrite a figure, it will display in large font. So you can see there the RMP is being changed to 0.3. VNAV altitude enable. I think this is one that isn't, or it's certainly becoming more common, but it was less common in the early days, and I think that was probably because flight ops departments didn't realise how useful it could be. But anyway, this came in with update 8 in 94. And what it will do is it will enable you to enable the aircraft to remain in VNAV when the MCP altitude's changed, either climbed or raised during a climb or lowered during a descent. And I've got a couple of examples there. So instead of it going to altitude acquire when you reach a particular level, you'll get one of the following two options. So if it's an MCP constrained altitude, rather than alt acquire, you'll get VNAV alt, and if it's a VNAV constrained altitude, or one in the legs page, then you will get VNAV path. So they're the subtle differences there in what happens. Both, of course, will cause the aircraft to level off, but it will remain in VNAV. You won't just simply go back to alt acquire. Next function is the AOC data link. So with this, it opened up the whole world of ACARs and the many and various options that come from there. These are just a couple of example pages, but there are lots and lots of different ones. And again, it's down to your airline which version they've chosen and what options are available. I won't go into too much detail. This is just a broad brush overview of what is available. I mean, to be honest, with ACARs and the like, that will be a whole video in itself, which I'm sure nobody wants to watch. Direct GPS input. This is this is one of two options which kind of go hand in hand on GPS, direct GPS input and GPS with integrity, which I'll do on the next slide. And what this does is this allows the FMCs to receive GPS position and time data directly from the GPSs or MMRs or GPS sensor units on the classics. If the GPS data source is GPI, then it monitors the input and provides the GPS status info to the FMC for fault determination. So in other words, the units are monitored by the FMC for faults, which of course pop up in scratchpad messages for us or alerts or what have you. So in other words, it's not just blindly following the GPS. It is actually monitored, and that's what this is all about. The other function which goes with it is GPS with integrity, or in case without the option, it's without integrity. So if this is enabled, then GPS data is used as the primary input for time and nav updating for all non-procedure segments of the flight plan. Obviously, procedure segments, then it's going to be more beacons and things, but that's what the with integrity is. If the GPS without integrity option is enabled, i.e. not with integrity, then the GPS data is only used for nav updating if the data is consistent with the nav aids in use, so terminal approach, en route nav aids, whatever they might be, or the IRS position if you're oceanic. So in other words, it will cross-check with nav aids. With integrity, it won't necessarily. if the option is available is enabled, you can see it either on the software options page or on progress 2 page, where you'll see a GPS track displayed down there, which I've boxed in red, and that will indicate which GPS, left, right, or centre, is providing the position data. Little note of trivia there that the FMC will not use flight deck clocks for date or time information when the GPS operational mode is equal GPS with integrity level. So there you go. I mean, this is always the case with the Max, but certainly on the NG, the clocks can provide the primary source of time data to the FMC, as they always used to on the classics, but they won't if GPS with integrity level is achieved. QFE altitude reference. This was a surprise to me when I discovered this a few years ago. I had no clue that that this was a thing. It's quite a rare option. I mean, there's only certain parts of the world where this would be of any use, but anyway, with it, as it says on the tin, QFE or QNH can be selected on the takeoff or approach ref pages, and it just shows up there highlighted when you select either QFE or QNH. There you go. Who knew? Select desired waypoint. This was actually one of the original pages, along with legs and a couple of others like climb and descent that were right there in the very first incarnation of the FMC. Anyway, got a little upgrade here in update 10 when they expanded it to a maximum of 12 waypoints over 2 pages. It used to be just 6 waypoints over 1 page. I had to search long and hard for a waypoint which would illustrate this. If you're curious, it's NDB November, which managed to yield this many similarly named waypoints around the world. I really not sure there was much need for this this development. But anyway, there you go. I mean, if anybody's going to get confused with something that's between 27 south and 53 north, then well, I'll say no more. But there it is. That's what it does, and they're listed in order of increasing difference. So really, distance. Sorry. So you don't really need to look much further than the first 2 or 3 lines to know which one you're going to select. RTA, again, this was quite an early feature, came in with update 4, but in update 10 it was given a little bit of extra functionality, and at and before or at and after windows were added, as you can see there, boxed. So those lines were not there pre-update 10. Radius turns, they're such a fantastic improvement. I used to fly the 737 before update 10, and there were certain departures I remember. I think Palmer 24 was one which had a DME arc, and we basically used to handball the 737 around a DME arc by adjusting the angle of bank against whether the DME was increasing or decreasing on the RDMI, which was great fun, and it's real flying. Those who are less confident about real flying, or if the weather was particularly bad, then you would possibly construct a DME arc manually by choosing a number of radials and distances and inputting them into the legs page. Anyway, update 10 came along, hallelujah, and DME arcs could be encoded. They could not only be encoded from a DME, which will be used in stars and approaches, but also any geographic point. So they could also be used as the turn center for en route legs as well. So yeah, dear me arcs, came in 97. LNAV at takeoff. So this, well, is just that really. It allowed LNAV control at takeoff. This was only for dual FMC aircraft, and not many classics were able to do this. I've got a rare photo of LNAV being fully engaged there before takeoff. They did change the logic very soon after to make it just LNAV armed. But there you go, I managed to get that photo soon after update 10 was introduced. VNAV below MCP, so this allows VNAV control descents below the MCP altitude, and you can see there at that lowish, relatively low altitude exactly what it's about. It's for doing your sort of LNAV VNAV engaged approaches. Again, it's one of those that requires an autopilot modification in the classics for it to work. But as you can see, this screenshot was off a Mac, so no such worries. Again, it's probably one of those functions that you take for granted now. But what I'm trying to do here is just show you the sort of genesis of the FMC functions. Navigation improvements. Okay, so with update 10, nav accuracy was really given a good shake-up, and one of the things it did was it went to the WGS 84 model for the Earth. Now, this let me try and explain this. The previous model was that the Earth was a sphere, and by that I mean a perfect sphere. I've shown that in the bottom graphic there. Now the Earth we know is not a perfect sphere. It's got mountains, it's got valleys, it's got troughs in the oceans. It is far from a perfect sphere. But not only that, it is not even loosely based on a sphere. It's actually flattened. It's an ellipsoid, and that's, well, crikey, we're going to get into astrophysics here, but needless to say, it is. So the red ellipse is a much closer approximation to the blue circle that I've drawn on that overlay of the Earth there, and the ellipse model is what the WGS 84, which is World Geodetic System 84, is based on. Now it's an Earth-centered, Earth-fixed terrestrial reference system, and it's got geodetic datum. Now there's a lot of sort of big words and big concepts in there, and by all means go Google it. But if I can, probably the best way to describe it, it's spherical coordinates. And it's all based on the datum being the centre of the Earth, and it's got that datum down to plus or minus 1 centimetre, so a 2 centimetre margin of error. So it's really very accurate, and probably the best way of describing what this spherical coordinate is it's like comparing, or it gets over the issues around map projections. So you've got Mercator's and Lambert conformals and they both look very different. Mercator's will stretch out the poles, make them look disproportionately big to areas around the equator. Obviously, you can't have that if you're flying from A to B across the globe. So WGS 84 gets around that. It uses this geodetic system of coordinates, and that is the standard used by all GPS systems. So what we've got here is a system which is now harmonized with the GPS, which of course became standard on the NG, which is why it came in with update 10, and that it can now talk the same language to your FMC for navigation. So that's what it's all about, and that's why it went to WGS 84. As a result of that, the next three bullets kind of follow: improved nav database lat and long resolution to 6 feet, an updated MAGVAR model. I'll talk about magnetic variation in the next video. Otherwise we're going to sort of get off on too much of a navigation tangent here. But the Magvar models, which are issued every 10 years, they are based on WGS84 coordinates. So again, they could be integrated much more easily. And improved AMP calculations, again as a result of the navigation improvements from going WGS84. So there you go. That's what happened then. A much easier concept to get your head round is descent now, which certainly when I first started flying the 737 was known as capture, and this is nothing more than a name change. It used to be called capture, and amazingly, I had a photo in my in my library stock of photos, and that photo has got to be 25 or 30 years old, of a capture prompt there on the descent page. And it's now just called descent now, and for those who've never used it or aren't yet flying the 737, if you select descent now, it will start descent at 1,000 feet a minute until it intercepts the planned idle thrust descent path. 150 knot speed constraint. This has now been added to all final approach fixed points for all approach types, and previously it was only assigned for ILS approaches. I don't know why it was never that way originally, but there you go. It now is. Minimum speeds. You can, with update 10, you can, and onwards, because this photo was taken, I think, on update 13. You can now manually enter the climb speed restrictions down to as low as 100 knots in legs. The previous minimum was 210, which was based on a lightish clean speed, but you can now go down to as low as 100 knots. I mean, obviously, whether it's safe to do so, you need to understand. The VNAV minimum limited speed is now also reduced to a safe increment above ref. So if you're in VNAV, that will protect you. Selected config is a function that was again added in update 10. This is a maintenance function. If you go to your initref index page and press select config, you'll probably see it just say data not available. The reason for that is that you have to have a certain system selected on the data load selector. So the bottom two photos show that I've selected, well, in this case, the D4do. You then press select config, and it shows you the config data, i.e. the software part numbers for the loadable software of whichever non-FMC system you choose, and that this is just for the engineers, so they can check that the software for those different subsystems is up to date. I say it's not only FMC software which is updated; the software for all kinds of other things is also updated as well. Again, more information about that in the FMC video. So 10.1 was issued very soon after 10.0, and all it was basically to include the 737-800. So the model engine database was updated to give the aerodynamic and propulsion data for the 800. And there was a new label added to it to allow different M1 limit values instead of takeoff M1 limit values to be used during a go-around, which is a very subtle change, but it was there nevertheless. They did also, apart from add the 800 in, they did put a couple of new features in. One of which was takeoff thrust bump. And for those of you who've not seen it, because again, this is not a particularly common option. Basically, this is the I shouldn't say it, but it's the least expensive way, or a less expensive way of having higher thrust engines. So what this does is it enables the engines to deliver indirectly more thrust. You get better climb performance, not takeoff performance. by the engines being able to have a higher pressure and temperature threshold limit inside. So the engines will effectively be a slightly higher thrust rating. So rather than have the engines permanently on wing at a higher thrust rating, you can go the cheaper route and have a lower thrust engine, which will do for 99% of your network operations. But if you need occasionally, if you've got one destination that you fly to which is a bit hot and high or short or what have you, then you've got the bump feature available. So it's just a cheap way of having higher thrust engines. While I'm talking about this, it's probably worth mentioning that for a great source of 737 performance information is from Captain Tiago Brenner from Brazil. He flies for Gol, and if you do a little search on YouTube for his videos, he explains. He's done a series of videos on performance which are excellent. I really do recommend them. He's also got a book out on it as well, which I've read, and I absolutely endorse those products. Anyway, that's takeoff thrust bump. The M1 limit pages were changed, which caught us by surprise when we jumped into the new aircraft, and all of a sudden the info wasn't quite where it used to be. So you've now got an on ground and an in-flight version of M1 limit. You didn't used to have it. The on ground one was just the same as the in-flight one previously. But this was brought in to enable selections of D-rates as well as climb thrusts on the ground. So it's hard to imagine operating the 737 without that page, but we did. Wet skid resistant runway was a condition which was added. This was after a lot of research work done by NASA onto previously runways had been either classified as wet or dry, but there was a kind of middle ground and the development for this was led by airports and operators that wanted to operate into the shorter runways. So places like Santos Dumont and Gibraltar. What's that one in Italy? Florence, is it? Which is really short and quite performance limiting. And those airports wanted the bigger airliners in. So that between them they did work on this, and the runways could either be grooved or have a porous friction cores, something which was quite sort of grainy in texture and would take away the moisture quite quickly. And what these do is they give you better friction. They kind of make a wet runway almost dry. They can't officially be classed as dry because they are wet, but they can be classed as wet skid resistant, and that's what this is about. So if the airport reporting it is is a wet skid resistant, approved by the authorities and by your airline, then you as a crew can select that. Takeoff speeds deleted message. This came in to ensure that there was no accidental use of erroneous takeoff speeds if any parameters have been changed. So if either the active departure runway, the wind, slope, heading, condition, wet, dry, skid resistant, whatever it might be, your flaps, takeoff outside air temperature, selected temperature, or the thrust rating, if any of those were changed, then the FMC would delete your takeoff speeds and show you this message. So you would then know to go and recheck your performance data, so you didn't take off with erroneous data. Flaps default value. This always used to default to well, it was usually either 1 or 5, depending on your airline. There is now an option not to have a default value, and if your airline no longer has a default value, then you will see boxes here which obviously need to be populated before you get airborne. That really is all there is to that. It's no big mystery to it. This one was again a maintenance thing. And it allows the engineers to do a download of FMC data for diagnostic purposes. So they plug into the data loader panel, which is that thing just above above and to the right of the jump seat. Stick a floppy disk in there or a data loader. Press this FMC download, and it squirts down all the data into the disk unloader, and away they go and analyze it. Again, more information about that on the FMC video. The VMO and MMO as seen or used by the FMC was changed. It was lowered down to 325 and .805 in the model engine database, and this was basically to reduce the potential of overspeeding, particularly in the descent. Certainly in those of us who operated the NG in the early days will recall some hair-raising descents where the FMC would actually command right up to VMO or MMO. So there's no fat at all in the descent planning. If you had a bit more tailwind, or if you're a bit late in the descent, then you were going to overspeed unless you intervened. Just went level change. So Boeing thought, okay, we'll give the boys a fighting chance. We'll reduce the FMC maxima to give the crew the opportunity to have a little bit of fat in the descent. So here we go. So decimal 805 or 325 on conversion. Again, you can override these if you want for RTA purposes, if you're feeling brave, and if you do, then they will change to large font. The nav database was given another boost in size from 125K to 2 meg, or it actually shows as words rather than bytes, which is why you kind of got a half the figure you see. But there it is there. Other changes, there was an overfly indicator in the navigation database to adjust the missed approach sequencing. So if that overfly indicator is set, then the runway must be flown over before sequencing the missed approach. If that overfly indication in the nav database isn't set, then guidance will be provided to direct to the missed approach point once active. So it just helps sequence things for the missed approach. And of course this is particularly of use if you starting to go around from well above minima. I mean, at minima you're practically over the runway anyway, so it doesn't matter. But if you're still a couple of miles out and air traffic tell you to go around, or whatever, you're unstable, you decide to go around, then it could make things a little sporty. So this overfly indicator is now coded into the nav database. Just helps us. That's all it does. 10.2 came out in September 1998, so again hot on the heels of the other ones, and this was just for the little mini NG, the 600 series. It also actually gave increased compatibility between the classics and the NGs with the A4 FMC, and a few bug fixes for update 10 and 10.1. So yeah, that's your model engine database for the 737-600. Only flew it a few times, but there it is. Managed to get a photo, and the nav database size was increased again from 2.5 meg to 5 meg, again shown in words there as 2560K. CDU color was introduced in 10.2. Again, hard to imagine life before a color CDU. And again, surprisingly, this was an option, an option that you had to pay for. I guess if you're into mixing CDUs, then you know there's a case for having them both non-color. But if you've got two color CDUs, then anyway, there you go. It's an option, and as with all options, you need to pay for it. I'll go into CDU color in much more detail on the FMC video, but I'm sure you're all familiar with that and the various uses of color on the CDU. The root hole page got a little update. That had remained unchanged since the first introduction of holes back with the very first Classic, and the quadrant and radial and target altitude fields were added. So always quite useful for extra information there. And I mentioned this earlier, the takeoff shift or runway remaining features, if you've got that option installed, is inhibited when GPS primary, when GPS is primary, and that's because GPS has got a greater accuracy than a toga trigger position shift. And the time you'll see this is when you've lost GPS signal. That isn't very often, but what certainly is being seen occasionally, particularly around the Eastern Mediterranean, and I was chatting to a 737 colleague who was at it was either Paphos or Larnaca in Cyprus. To his surprise, as they were taxiing out, they got this takeoff shift prompt on the takeoff reference page, and they hadn't seen it for years, thought it had long since died out, but it had come back because they'd lost the GPS signal being jammed, as it often is in the Eastern Mediterranean at the moment with the military situation out there. So the military are jamming the signals. That will pop up if you got the takeoff ref page displayed. High altitude manoeuvring was given an improvement. Lots of changes here, and basically what they did was they used the thrust-based roll limit instead of fixed angular bank roll limit. So I mean, fixed angular bank is fine at low levels, but in the early days of LNAV, the angle of bank would go up to 28 degrees. You really don't want to be rolling 28 degrees at flight level 410 in a heavy 700. Well, in any 737. So thrust-based roll limits came in. I say to correct the problem of insufficient thrust for high altitude, large bank angle turns, which result in the inability to hold target speed. Well, obviously, no kidding. 2 new FMC warning messages were added in case that reduced bank angle creates a problem with staying on track. The first was unable to hold airspace. So if you're doing, and again, this is only going to arise if you're doing a particularly high altitude hold. But if you are, and the thrust limited bank angle is not enough to give you to keep you within the confines of the holding pattern, then you get the unable to hold airspace message. The other one is LNAV bank angle limited, and that's when if LNAV's engaged and you're within 5 minutes of a turn waypoint, and the FMC looks ahead and indicates that the airspace is violated. In other words, if you're going to pop out the edge of the airway, that's usually what it means. Then you get LNAV bank angle limited warning. I have not actually seen either of those in all my time flying the 737, but that's I'm sure people have. Some other features, the FMC now will recognise localised direction aids, simplified direction facilities, and instrument guidance system approaches. They're all now in the navigation database. The descent path algorithm has been changed to change the pitch mode from VNAV path to level change, and that kicks in about 7 knots below the VMO MMO speed limits. Again, this is to reduce the potential of getting an overspeed. Pre 10.2, it wouldn't change until you'd actually hit or bust VMO MMO. The V-speed unavailable message, it's been improved to account for additional conditions that might fail the sense check of V-speeds. So it used to be just V1 less than VR less than V2, but now it'll include things like VMCA, I think VMCG, possibly VMBE as well. And there was another feature added which automatically corrects an altitude mismatch that you can get at an approach boundary, and that would arise when the first approach waypoint is linked with an en route waypoint, and they've got 2 different altitude constraints. So it's which one do I follow? But that kind of bug fix, if you like, was fixed with 10.2. 10.2A. Talking of bug fixes, was a bug fix for 10.2. This came out in December '98, and it just fixed a couple of errors that crept in with 10.2. And again, this is no shame on GE or Boeing and anyone. Anybody who's done any software coding will know it's statistically impossible beyond a certain length of program not to introduce bugs, and these guys are no different. And trust me, the checking methods to iron out the bugs, to find and then iron out the bugs, are really very, very extensive, both at the programming stage and in the pre-certification flight testing stage. A lot of buttons are pushed and a lot of scenarios are enacted to try and find bugs, but a couple do get out onto the line. Anyway, the 2 that were addressed here were one which caused the FMC to lock up when the descent key was pressed within 10 seconds after executing a modification, but before it had completed the descent calculations. In other words, you've gone too fast for the computer to keep up with you. And the second one were given an incorrect in-flight initialization after a long-term power interrupt or FMC restart. And this was only on dual FMC aircraft. You could fix it by moving the source select switch if you're on a dual FMC aircraft, but if you're on a single FMC aircraft, then it could take up to 8 minutes to resolve itself. Again, I never had this one in my time with 10.2. But you can imagine being in flight without an FMC for 8 minutes. I mean, if you're just en route on an airway, no biggie. But if you're in the descent or about to start an approach, then 8 minutes could seem like a lifetime, I'm sure. Anyway, that was fixed with 10.2, or sorry, 10.2A. That's it. That's I certainly can't run all the way through to 14 in one video, so we'll stop it there, and we'll come back to it with the next video, and look at 10.3 to 10.5A. So as always, if you've enjoyed this video, please give it a like, subscribe to my channel if you haven't already done so, and just want to say shout out to everyone who has done so. It's just flicked over 10,000 subscribers. And if you really want to show your appreciation, get a copy of the book. Keeps me in beer. All right, thanks very much for watching.